Northwestern Pennsylvania Beekeepers Association presents.
Kathy discovered that she had another commitment in Cambridge Springs today that she didn't have on her calendar. So anyway, my wife Kathy is the chairperson for the Pennsylvania State Beekeepers Honey Queen program. And this year we were fortunate to have two girls that fulfill the roles of Honey Queen and Princess. And the unique thing is we have one from each side of the state. And today we're pleased to introduce Natalie Shimon from Mercer. And I'm going to let her give you a little spiel of what she's up to.
Give it up here for Natalie.
Hi everyone, as Charlie said, I'm the 2023 Pennsylvania Honey Princess. I'm from Mercer. I've been beekeeping since 2008. My dad started in 2007. I lost track now of how many events I have done since January. I've been to the farm show. I was there for 3 days. Just finished an event this Wednesday with the Butler County Master Gardeners and have 3 events this week, one with my own kindergartners for the whole week. They are very excited about that. They've been pestering me since November. I still have lots of openings. If you guys hear of any community events or school events, I would love to be able to come out to events and talk to kids and adults about honeybees and beekeeping.
I have the impression that you are a kindergarten teacher at what school district?
A private school, Creative Learning Christian School.
Oh, interesting. How many pupils do you have?
I have 8 this year, 11 next year.
Do you enjoy your work?
Love it.
Thank you very much again. Okay. Vice President Cece here. She's going to introduce, we're going to get our Zoom going here. And our guest speaker, do you want to talk about the two different things she's doing? That's right? 2? Okay, you're on.
Okay, so Robyn Underwood, we're going to see if we're running a touch early, amazing. See if she's on yet, but yes, so Dr. Robyn Underwood, she earned her PhD studying the use of formic acid to control mites on overwintered honeybee colonies in temperature-controlled facilities in Canada. So she now works for Penn State Extension, and she conducts a lot of applied research. We're going to be hearing from 2 different studies that she's done. One is comparing different systems of treating for mites and just management styles in general. And the other one is a local comparison study of different queens that our own Charlie Forsett had in his mating yard, as well as other places in Pennsylvania.
Recording in progress.
So Dr. Robyn Underwood acts as a propolis for beekeepers and education. She squeezes the 2 together in the eastern part of the United States. She is an awesome mentor and person in general. Let's hear from Robyn.
I sure wish I lived closer so I could be there in person with you guys, but Zoom is a blessing, is it not? First, I'm going to tell you about what we call the COMB studies. So COMB stands for Conventional and Organic Management of Bees. And I'm very, very excited to say that this study is now in print. So I'll give you the link so you can read the paper yourself. Just came out a couple of days ago. So as you know, bees are facing lots of stressors from all kinds of different angles all the time. But as a beekeeper, I feel like what I can control the most is my beekeeping practices. So I can't control what a farmer down the road is spraying. I try to avoid diseases, of course, in my bees. But what I do as a beekeeper can really make a difference. So practices and attitudes are really important. So that's kind of what this research project was focusing on. And I'm guessing that the people in this room each have sort of a different philosophy toward how they manage their bees, and so we we like to talk about your attitude or what guides you in your behavior. And in beekeeping, this is sort of your attitude toward what is your role as the beekeeper. And we we like to look at it as a system. So it's not any one decision that you're making or any one thing, like whether you're feeding pollen patties or not. It's many, many things. So this paper, you can see the link at the bottom. It's uh, freely available online, is about beekeepers. So I'm an entomologist. I don't generally study people, but for this paper, we felt it was important to describe beekeepers and how they're managing their colonies. So in this paper, we kind of look at beekeeping philosophies and the management practices associated with them using bee-informed partnership data that we were able to get our hands on. And we came up with this crazy, colorful continuum that I think once you understand what it's showing, you may like to use this, especially in a beginning beekeeping class where people are coming into the class with preconceived notions about what beekeeping is like, and they can't really figure out where they fit in, or if you're trying to still figure out where you fit in. So I'm not going to go over the whole entire thing, but I just want to describe in general what we can see here. So on this sort of table, we have basic categories. Um, what are your choices in terms of chemical use in your hives, hive manipulations, feeding of the hive of the colonies, and what are your goals? The goals are very important. So for example, here, if we look at varroa mite treatments, um, if you refuse to use chemicals at any time, you would be someone that has very low intervention for this particular item because you're not intervening using chemicals. If, on the other hand, you use essential oils like thymol in the form of Apigard or acids, which would be formic and oxalic acid, you would be sort of medium. If you're, on the other hand, using synthetics, so for that, that would be Apivar, our Amatraz treatment. I consider that to be the highest intervention. So when we were thinking about intervention levels, I chose high for synthetics, number one, because they not only have a 6-week treatment period, but 2 weeks before you can put the supers on, but also that even when you remove the strips, that pesticide is remaining in the hive. So that's a much higher intervention than, say, formic acid treatment that lasts 2 weeks. It has dissipated and you remove the pads and it's gone. So that's just one example. Then we have here with, you're down to the next category, hive manipulations. Are you doing nothing for varroa mite control in terms of cultural controls? Or are you somewhere all the way to the right where you're fundamentally changing the size of the bees by using small cell comb? So what I like to do if I'm there in person, or a club could do this, sort of hand out a copy of this picture to everyone in the room and have everyone circle what they do. So when you go home, you can go ahead and find this figure online in this paper, print it, and circle your answers. So if you do so, it may look like something like this. So maybe you like to keep yourself organic, but you don't do anything because these other small hive beetle and nosema are not a problem for you. You use drone brood removal. You're not really replacing queens unless you have to. Um, you're interested in making money from your beekeeping, so you produce honey and bees, etc. So if you go ahead and do this, what you're going to have in front of you is what we call your management system. So it's a whole system. It's multitudes of questions that you're answering and talking about how you're going to manage your colonies. So again, if I had everyone circle their answers here, we would be able to then place you in a category depending on how you answered. And for the purposes of the paper about beekeepers and our research, we have broadly lumped people into three categories. The first is a conventional beekeeper. So these are people that are willing to do anything across the spectrum as long as it's, of course, as an extension educator, I'll encourage registered products and following the label. So if you don't mind using anything for your bees, including synthetic chemicals for mites, you would fall into the conventional category. If, however, you are monitoring and managing for mites, but you don't use synthetics, you would always use the acids and oils, then you would fall under the organic treatment, organic system. If you don't ever use chemicals in your hives, then you would be in the chemical-free system. So these are the three broad categories of beekeepers, and I fully realize that within each of these, there's still a continuum. But for simplicity's sake, we broke this into three groups. So based on that paper where we looked at beekeepers, we moved forward with a research project. So each one of you, I'm sure, would hand this paper out over and say, this is the best way to keep bees. I keep the best, healthiest bees. But you can't all be right? Not everyone can be best. So we wanted to compare these side by side in a controlled manner and collect the data, right? I like data and graphs, and I like things proving themselves over and over and over on a large scale. So we did this with full-size honey-producing colonies. We managed our apiaries with the goal of producing honey, having high overwintering success, and splitting colonies as needed, and being able to sort of sell off the extra colonies that we had. So we were producing honey and bees, and we acted like a sideliner, so like a medium scale operation. Here at the bottom of the page is the link to the new paper that most of you haven't seen. I only sent out an email to my most important collaborators this morning, so they might not even have seen it themselves. Excuse me. Okay. So in order to figure out these management systems that fall into these three categories, we gathered a group of 30 beekeepers from across Pennsylvania. You probably are familiar with many of the faces here in this group. We gathered in 2017 in the fall and spent the whole day figuring out what are beekeepers actually doing. So Margarita and I don't like to sit around in our office and pretend that we know what everyone's doing in their apiaries. So we asked beekeepers. Funny enough, when we set up for this group photo, the groups kind of came out together. So generally on the left, we have our chemical-free beekeepers, and sort of in the middle was more organic, and on the right, conventional. So I assume you know some of these people. Karen Rakaseka here is our state apiarist. You have, Charlie Voracek, Steve Rapaski, Steve Fink, Mark Antunes, Vince Aloyo, Marianne Frazier was there, Mark Gingrich. And we also invited the inspectors to come because we figured they have seen apiaries in all of these different management systems. So we're very thankful to these people because they were able to really be the boots on the ground that created the systems. And by the way, even though they don't generally get along at beekeeping meetings, they got along very well this day, and we got a lot accomplished and set up this project. So this figure here is very loud and very complicated. In past talks, I've shown a crazy table to explain this, but when it came down for publication, they really wanted like a picture. So let me explain to you what you can see here. So there are 3 hives, one for each management system, and it's really summarizing what we did with this system. So we're going to start on the left with conventional. So what you can see actually is that all of these colonies were in 8-frame Langstroth equipment, all mediums. The bottom 2 boxes had 8 frames and a feeder on the side. All of them got fed Pro Suite if they needed to be fed liquid food. With conventional, they had standard foundation, a screen bottom board. We used a queen excluder above the 3rd medium. By the way, 3 mediums is the equivalent of 2 deeps, so this is double brood chamber management. And in winter, they received a candy board. In the middle, we have organic, again, standard foundation. However, these had a solid bottom board and no queen excluder. And we also used drone brood removal. So in the bottom 3 brood chambers there, they each had 1 drone comb that whenever we would see capped drones, we would scrape them off because that was our mite trapping technique. In winter, if they got emergency feed, it was just dry sugar. And in March, they would get like 1/3 of a pollen patty boost for spring. On the right, we have chemical free. So chemical free had a solid bottom board, no queen excluder, but the foundation was different. So we gave them small cell foundation, and also on each side of that foundation, it was just open space. These beekeepers felt strongly that the bees needed to have as natural a state as possible, and that they like to have 10% drone brood. So we gave them 10% of space to do what they wanted. And for the most part, they did have drone brood in those sections. Also, we encouraged them to build out the propolis envelope. So the insides of all the boxes were all scratched up rather than being smooth like new normal boxes. And the inner cover was a piece of cotton duck. So it was just cotton fabric cut to the size of an inner cover. And absolutely, they propolized that like crazy. It was pretty cool to see. Okay, so let's summarize the differences. Conventional and organic had standard foundation, while chemical-free had small cell. Organic used drone comb as well. Only conventional had a queen excluder and a screen bottom board. Otherwise, no queen excluder, no screen. Okay, so what did we do in terms of treatments? Well, year 1 was a total establishment year. All these colonies were given brand new plastic foundation that they had to draw out. And so being newbies, the mite levels didn't build up very high. So basically when the packages were installed, conventional and organic got an oxalic acid treatment before they had brood just to knock down any mites that we thought might be in the packages. And by the way, there were really no mites. It was pretty unfortunate because we wanted to look at the mites that fell onto the screen, onto the sticky board for research, and we couldn't even do it. There weren't enough mites. So it was clear that they were probably treated previous to the making of the packages. Anyway, then we monitored mites throughout the summer, and they never got above the threshold, so we didn't have to treat. But in the fall, no matter the mite levels, the conventional treatment got amitraz, and the organic got formic acid. They all then also got a one-time oxalic acid vapor between Christmas and New Year's. Then the following spring of each of the next 2 years, organic would get an OA vapor one time in March, like before you could even open anything. And then you'll see these next two boxes here have a star. So we basically set out to um, have treatments available as needed. So if in this time of year the colonies got above the threshold of 1% of mites, then they could get an oxalic acid treatment. If later in the summer they got above the threshold, they could get a formic acid treatment. And then in the fall, again, conventional blanket treatment, no matter what, got amitraz. In the fall for organic, it was also a blanket treatment, but we were using an integrated pest management approach with rotation of chemicals. So if those colonies had already had formic acid, then their fall treatment would be Thymol. If they hadn't had formic acid, the fall treatment was formic acid. So I hope that makes sense. And then again, Merry Christmas. Here's your OA vapor. So this was a large-scale project, well replicated, starting with 288 colonies, and they were split into 8 different farms. So each star is a farm. We were spread across Pennsylvania and had a replication in West Virginia. Each of these stars is, we call a farm. That farm then had 3 apiaries. So you can see 1, 2, 3. And each apiary had 12 total colonies split into the 3 different treatments. So these were literally side by side. I'm sure you understand the critical nature of the actual apiary location, how it can vary drastically, even like up a hill, down a hill, 100 meters away. So it was critical that we have all the treatment groups, all the systems at every apiary. So yes, the answer is yes, we had totally untreated colonies next to treated colonies in our apiary. So we would start with 12 colonies, 4 in each treatment system, and the order of those 3 varied by apiary so that it wasn't always one on the one end or the other, so they could be mixed up. Like you can see that here, where chemical free is in the middle here on the left side, so that was pretty important. This project started in April of 2018, and we ran continuously through April of 2021, tracking those colonies that survived throughout this time period. Clearly, putting packages from Georgia into a chemical-free management system, I'm sure there's no way that they would survive. But we could not get mite resistant or some treatment free line of bees that had 288 packages for us to buy. So what we had to do is just purchase packages. I called those my comb builders. They started up the colonies, they built up comb, and then as soon as we could, which ended up being July, we requeened those colonies with the best queens we could get. So these queens were sisters, so they were sorry, they were grafted from the same colony and open mated. That colony had lived in the soffit of a house for 4 years, totally unmanaged. Then they were a cutout and put into normal equipment where they were untreated for 3 additional years. So having a colony surviving for 7 years is a very good sign that they can resist mites. So we had sister queens made for all of our colonies, and we requeened all of them as soon as we could. So now we have all the same genetics. Genetics matter, and you'll see that a little bit in the second half of my talk. So these were all the same. And now when we see differences, it's because of management. Now, I'm not pretending that these queens lasted for 3 years because they clearly didn't, but we never purchased any more bees or any more queens. If they requeened in place from descending from these queens throughout the time. Every month from April through October, we would do a varroa mite wash using an alcohol wash. Every fall, after all the treatments were done, so this would be early October, we would take samples on dry ice to bring back to the lab so we could look at their immune systems, their levels of nutrition, nosema, and virus loads. And every year of the study, we looked at how much honey production each colony made. Um, and of course, overwintering survival is very important. So those survival numbers are which colonies were alive in October, and then which ones were still alive the following April. So let's look at honey production. This is how much honey production each apiary made. And you can see that the conventional and organic colonies made more honey than the chemical-free apiaries, but they were not significantly different from each other. You can see that organic was slightly more honey produced than conventional, but that was not significant. So when you see these graphs, by the way, they're always color-coded the same and always going to be in the same order. So we have chemical-free in orange, conventional in purple, and organic in green. And when you see these letters, the A, B, B, that's telling you what is significantly different from each other. So if they have the same letter, like here, BB for conventional and organic, those two were not significantly different from each other, but they are different from C, the chemical free, which has an A. So that's kind of how these graphs are going to work. So ABB, you're going to see that quite a lot, actually. What did it look like in terms of mites? So this is like a fine scale of the monthly mite washes and how did the mites look over time. And I like to show this because what I'm showing you really is that throughout the season, we were able to keep mites below the 1% in all of the treated colonies, right? So both years, you can see that the mite levels stayed quite low throughout the time. Another thing I want you to notice, and we didn't really run statistics on this, but see that conventional and organic are virtually running the same, right? So I don't want to say that this is definitive, but it doesn't seem that the drone brood removal made a very big impact on the mites, although there is really slight differences here in the third year where maybe. But what you can definitely see is this orange line goes up to 4% on average in the first year, and much, much higher the following 2 years. So these mature, overwintered, established colonies had very, very high mite levels. And we definitely, at the time, saw like really bad parasitic mite syndrome going into winter. And you'll see overwintering success next slide. But really, these untreated colonies that had high mites, they didn't die in March. They died right away by November, like as soon as it got cold. Some people often ask me, well, how did the mite numbers go from really high to really low the following spring? And basically, you can only do a mite wash on living colonies. So, in spring they were low. The colonies that had survived the winter had low mites the following spring. So on average, then, this is sort of our October. So we did like a snapshot of colony health each fall in October and measured many, many things about the colonies. And one of them is varroa. So to summarize, this is what the varroa mites looked like each fall going into winter. Very low in the ones where we used chemical controls. We did have a bit of a control issue the third fall. And these colonies were sampled, and I'm going to recommend to you, always sample after your treatment. So that's what this is. This is after the chemical treatments with amitraz and, formic acid. So what we did at that time is we did 3 oxalic acid vapors a week apart going into winter, but we never measured the varroa mite levels after that because it got too cold. So we, like I said, do your mite control, but then also sample afterwards to make sure that it worked. And if not, you may need to do something else. But you can see clearly here that there's many, many mites in the chemical-free system. So what did that do to the bees in terms of viruses? So here we have deformed wing virus, and you can see that the chemical-free colonies had more virus, significantly more virus than the others. And again, conventional and organic are not significantly different from each other, but organic was slightly lower. Nosema is sort of an interesting wild card in here. We didn't do anything specifically to control Nosema, which, by the way, did you know it has this really weird new name, Viremorpha? Anyway, so Nosema, and this is Nosema cerana, right, or Viremorpha cerana, because the Apis species was super rare, so it's not even fun to show the graph because it's almost always not present. Anyway, so you can see here that the chemical-free had the most. They had significantly more than the organic colonies, but conventional was halfway in between. So conventional wasn't different from chemical-free, and it wasn't different from organic. But organic had less nosema than chemical-free. So in terms of the lab tests, this is vitellogenin, which is made in the fat bodies, and it's a sort of looks at their nutritional status, and you can see there's no letters here because none of these are different from each other. So having them in place in apiary side by side, they had access to the same, forage, and so their nutritional status was no different. In terms of their immune system, what you're looking at here is 3 different immune genes that are part of different immune pathways within their immune system. And all 3 of them had the same basic trend. The chemical-free bees, so they had more mites and more virus, and their immune systems were much more active, having to fight off things. So again, you can see chemical-free versus the ones with mites kept under control. They're significantly different. And what did that mean for the bees then? So that October snapshot is their health going into winter. How well did they then survive the winter? So again, each year we looked at how many colonies were alive in October and then how many survived through until April. And each year we had excellent survival in the conventional and organic systems. So both of them work very well, keep mites under control, and keep their immune system from being too active and control viruses. And therefore, we have great overwintering success. Unfortunately, without those chemical treatments and being able to intervene, we had very poor survival for the chemical-free colonies. Now remember, we did put in the best genetics we thought. We had great genetics, came from a line that wasn't being treated for a very long time, but even so, they were not able to make it. So the first year, only 35% survived, then 25%, and then, another like 40%. And so you can imagine that these numbers, since we followed colonies continuously over time, went down and down and down. We would try to, well, anyway, never mind. So this is what it looks like over time. And so you can see that in the chemical-free system, we began with 96 colonies, and by the end, we had 1. So that was very, very poor survival. And you can see that also for conventional and organic, having a continuous colony is pretty tough. So think of it in terms of like, you can't bring in a new queen, you can't split. I mean, you can't have a split count as the parent anymore. So this is, you know, this isn't normal beekeeping. This is research beekeeping where that colony in that hive sitting right in that spot is the continuous colony. Um, we did do splits and have swarming problems, and so that's where the summer losses occurred when the queen failed to return, and we ended up with some laying workers. But still, I would much rather have, this many colonies remaining rather than just one. So this figure here is a crazy wild summary of all of that information. So what you're looking at is the light color is a positive effect, and the red is a negative effect. And the thickness of those arrows is a larger effect is a fatter arrow, right? So overall, colonies in the conventional or organic system had very much positive survival compared to the chemical free. It also, if you're in the conventional and or organic system and you're a honeybee colony, you're going to being in that system has a negative impact on mites. That's great. We don't like mites. Negative impact on nosema, negative impact on the amount of deformed wing virus and how your immune system reacts. So it's a good thing to be in the conventional or organic system. If these things are present, you can see that varroa mites have a negative impact on survival. So does nosema and virus and immune system stuff. So this is kind of like your general summary that is quite intuitive, and I'm guessing not a big surprise to you. So really, in a nutshell, to summarize this, I feel very strongly that if the bees cannot keep mites under control, it is the beekeeper's job to do so. You cannot put your head in the sand and not watch for mites. So doing some monitoring is critical, especially later in the season. So if you want to skip it until July, go for it. But at that time, you need to start monitoring. If the mites are over a threshold, which we used 1%, I would still be comfortable at 2%, but not 3%. You need to control those mites, and that must be done early. So we treated our colonies in the second half of August so that all of the winter bees could be made without mite pressure, right? So the supers came off, and by the last week of August, so sorry. By the last week of August, they were down to their 3 mediums. We were able to treat even those long-term treatments, and then by October, they were in really, really good shape. So fall treatment, please remember, really means late August at the latest or early September. It doesn't mean October. That's way, 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 way too late. The other thing is, I hope that what you saw is that the organic and the conventional management both were stellar, right? So to me, that means why in the world would I need to use synthetic chemicals when I do not have to, right? You can have excellent overwintering survival, great honey production, and super healthy bees without amitraz. I don't want to hear anyone saying you can't manage mites without amitraz because it is just not true. And we prove that. So consider trying to get away from those synthetics. Resistance to them is at our doorstep anyway. So let's transition over to using those other 3 treatments. And I assure you, you'll have good success. So again, I'm really excited that this is in print now. You can, if you didn't catch the link, I can share it with CC or somebody to share widely, or you can try Googling it. I did that this morning and it came up. And I don't want to make it sound like I did this by myself, because absolutely there was a huge team of people involved, people in the field, the stakeholder group, etc. It was a huge undertaking. Different states, lots of people. I'm really proud of of these results. So I think I'm going to go on to the queen comparison, and then we can have all of our questions at the end. So I hope that's okay. So I guess one of the things about that work is if I could do it again, I would try to pick a different genetics, right? I would love to find the best queens possible that are proven to be able to keep mites under control, because I do believe that the future of beekeeping is in genetics and breeding. So I'm not saying that no one can ever keep bees without chemicals, but in that case, those bees needed the chemical intervention, and we need to pay attention to our mites. That's sort of the story there. But when you go ahead and you want to buy some queens, where are you buying these queens? Which breeders are you choosing? Which lines are you picking? And why? Do you trust the breeder to tell you that I have queens that do such and such? Do you ask beekeepers nearby? Which queens do you buy? I often see that new beekeepers are told to only get Italians. What even bees are Italian? I mean, they're American and probably mutts everywhere you go. So anyway, when you get into beekeeping and get, established and you've got it all figured out, after 3 to 5 years of having some colonies, perhaps then it's time to start choosing more specific queens, right? And so when you are picking a queen, you're asking around, should I get Russians or Carniolan or Saskatraz or Italian? Should they be northern? Is southern okay? If a northern breeder brings queens to the south to breed, is that okay? Are they called Pennsylvania Hardy? What are they? Do they have traits like varroa sensitive hygiene, hygienic behavior, mite biting, whatever? It's like really crazy and confusing, right? There's not a really good guide to which ones work best. And then if there is, was it done in Pennsylvania or California or Georgia? So we set out to try to help you figure that out. And so we looked at different honeybee stocks. So what even is a stock, right? So it's a population of honeybees that displays a particular trait. Perhaps they're VSH, which is for varroa sensitive hygiene. It's become clear that beekeepers are willing to pay a premium for a specific stock if they believe that it's going to perform better. But where is the evidence that they actually do? That's what we set out to do for our area of the country. And so we collaborated with Purdue University in Indiana and beekeepers across Pennsylvania, which were kind of in the same climate. And we wanted to see how some lines of queens or stocks of queens perform. So what are the traits of interest? Clearly, we want to have bees that collect lots of honey, because if we're trying to make a go of a business, we need something to sell. So we want to have good honey producers. We also do not want mean bees. We don't want to be like having no fun in the apiary, right? We want calm, fun bees. And we also would really like them to be somehow able to stand up against diseases and pests, right? So maybe they're resistant against chalkroot here at the bottom, or they have mite biting tendencies, like you can tell happened here with this mite with its legs bitten off. We don't want them to always be getting sick like I am today, right? So for this study, we had beekeeper participants. So we didn't manage the bees ourselves. We asked for beekeeper helpers to manage these bees for us. So in Pennsylvania, we had 10 different beekeepers. You can see we spread them all across the state, 2 up in your area, 2 farther south, 2 in the middle, 2 southeast-ish, and 2 northeast-ish. And each of them was asked to dedicate 20 full-size colonies to this project, put them all in one apiary. In Indiana, they only had 5 collaborators, so some of them had 50 colonies each. So 50, 50, 50, 20, and 30 made up their 200, whereas we had 10 beekeepers with 20 each. So either way, 200 colonies were monitored in each state. And so full-size colonies were requeened with the queen lines of interest. So this is the queens that we chose to study for this. We got Georgia queens and California queens. So these are things that are commercially available where, most people are buying these this time of year. In fact, I myself just hived 12 packages yesterday from Georgia. But I will be requeening very soon. Anyway, so Georgia and California in comparison to a Pennsylvania hardy stock, an Indiana stock, which descended from but is not officially mite biter stock. And then we had Russian bees as well, certified Russian breeder queens. Sorry, they weren't breeder queens, they were from a Russian breeder. So all of these queens for all of these colonies were created at the same time and shipped and actually arrived at my doorstep on the same day. It was absolutely amazing. It all worked out. So these, I got the breeder queens from each of these, and then I made little sets, one for each of the beekeepers, and then distributed them to get them put into the colonies. So here's our timeline. We started this in the summer of 2020, where June 15th was our target date for requeening. The beekeepers were asked to do assessments every month, and I would come out and work side by side with them and do a fall assessment, a spring assessment, a fall assessment, and a spring assessment. So this was about a 2-year study where the middle year was like a full bee season. So that's where we could look at honey production and things like that. So we measured all of those things that are of interest. One of them is temperament. So this little table here is something that I have on my data sheets for my bee yard, where I like to figure out like how aggressive are the bees? Are they super calm and I could work without a veil? Well, I don't like working without a veil, so I probably wouldn't, but most of the colonies come out as a 2. They're calm, you can wear a veil, smoke here and there, no big deal, all the way up to these extremely aggressive, Velcro to the face kinds of bees that, of course, we don't want. So we wanted to measure temperament, and we used this scale from 1 to 5. Honey production was measured for each colony. This is Charlie Vorosek's yard. Thank you, Charlie. And you can see how very meticulously each box was marked with the queen's number. And so this box would be weighed before and after extraction to see how much honey that colony made on an individual basis. And so all the honey from the whole year was just lumped together to one number of honey production. Alcohol washes were done monthly, and the beekeepers were asked that if an individual colony was over the 2% threshold, that they would treat. And we had sort of the same treatment regime that you saw in the previous study, where certain chemicals were allowed at certain times of the year. But really, it was a colony by colony basis because, I'm not ever saying that you have to use chemicals or that you have to use them on a schedule or anything, but you have to monitor and respond, right? So don't treat if they don't need it, but do treat if they need it. So that's kind of what was happening here. Again, we collected samples in the fall to do lab testing, just like with the other study. We measured a little bit of different things, but okay, so here's the results. In terms of honey production, during that one full year, you can see that yellow or Indiana far outpaced the others and significantly made more honey. Then you can see next up was pink, or the Pennsylvania hardy queens did all right, but not quite different from the Russian or the commercial bees from Georgia and California. So Indiana were great honey producers. followed by Pennsylvania. When I visited in those spring and fall times, I measured brood area, estimating how many frames of brood there were. And you can see here that it kind of varied over time. We didn't really run any statistics, but the first fall they were pretty equal. Coming out in spring, though, you can definitely see that Indiana was stronger. The Russians were pretty strong as well. So it is possible, and we haven't looked at the data, but it's possible that strength in spring then led to the higher honey production. So you want strong colonies. I hope your colonies are strong right now. And then come fall, you can see like not too much of differences, but going into winter, those commercial Georgia and California were a little bit weaker in terms of brood production. Temperament was really, really tough. As you know, aggression is not just, consistent. So you can have colonies that are bothered by a skunk, or, there's a dearth or whatever, and you may, temperament is all over the place. So probably when we publish, we're not going to use this data, because also beekeeper matters. Like maybe you think they're mean, but I don't think they're mean. So sorry, this data isn't very good, but I wanted to show you anyway. And have you think about that, like if you have a mean colony one day, it's not like you need to get rid of it because it may be nice the next day. Okay, so in the lab, we looked at some things. Of course, we looked at deformed wing virus, only this time, instead of just lumping it all together, we split it out into those two types, deformed wing A and deformed wing B. We also were able to quantify the mite biting gene. So someone has isolated nerexin as being an indicator of the bees being able to groom really well and damage the mites. So we looked at nerexin. And then there was also a paper published about hygienic behavior. And there were two genes that they associated with that. One is odorant binding protein and the other one's syntrophin. So we decided to look at that as well. So in terms of deformed wing virus, for both strains, A and B, you can see that the California and Georgia colonies in the fall had more deformed wing virus than the other three stocks for both. And you can see also, although it's not significantly different, but the Indiana bees in terms of deformed wing B had a really small amounts of deformed wing virus. So they seem to be great. In terms of the mite biting gene, I'm sure Indiana breeders are happy to see that their bees have, lots of mite biting, but it does appear that the Pennsylvania stock that we used also has some mite biting capabilities, unlike Georgia and California or Russian bees. Russian bees are not known for this anyway, so this is just sort of confirmation. And then we have our hygienic genes, and you can see here A's all over the place, which probably shouldn't even be there at all. There should be no letters because there is no difference in hygienic behavior. And really, we were not targeting bees with hygienic tendencies, known hygienic tendencies anyway. So that's kind of interesting. And so our goal then is to really be able to make a table like this. I sort of just read through the data and made this up. First of all, what are the things that you're interested in knowing about before you purchase a queen? Do you want them to be good honey producers, have a large population? Do you care about temperament, deformed wing virus in fall, if they have mite biting or hygienic behaviors? So those are the things we measured. So what you can see here, there's no pluses in Georgia or California. They really did not perform well compared to the others. But what I see here is Indiana, had stronger colonies making more honey, and that resulted in less deformed wing virus and more mite biting. And Pennsylvania did all right as well with great honey production. lower deformed wing virus, and some mite biting. So I guess if I was going to tell you, if you wanted advice on which queen should I buy out of these 5, I would say local is better. Northern performs better than Western or Southern queens, so don't buy a packaged queen. But look for a Pennsylvania breeder, or maybe try to get back to that Indiana breeder for your queens. So what was of interest was that the beekeepers involved were asked before they were able to see that final data which queens they liked. And so I feel very confident they know what good queens are, because most of them really, really liked the yellow line. That was Indiana. And some of them said, and the pink was pretty good. That was Pennsylvania. And our data really did show that they were better. So good job, guys, in being able to see that in your everyday. So this isn't yet published, so it's still preliminary. And of course, when I give talks before something's published, the data change over time because we kind of, play around with different ways of displaying it and things like that. But it does seem pretty clear that our local or northern queens did outperform those from Georgia and California. So our next step then is this summer we're planning to do that full year study of several Pennsylvania lines, because we have lots of great breeders here in PA. And so last year they gave us 10 queens each. We had like 7 breeders that gave us those queens, and we put them into colonies. So now we're kind of regrouping to see who made it through the winter and stuff like that. This time I'm managing the colonies, and all I know is their color. I don't know who the breeder is. By the way, the color coding of the previous queens, those beekeepers did not know what the lines were, and they did not know which was which. So it was pretty great for them to always be chatting and guessing and trying to figure out which lines they were. Well, now it's reversed. So now I don't know which lines they are, but they do. So I'm just collecting data like I always do. So lastly, I just want to thank everyone that was involved in that study, and thank the late Queen Elizabeth for her wonderful outfits for this project. And then just before I finish, I want to let you know that there's a new version of the Field Guide to Honeybee Melodies that's out. It was out of stock for a little while because I guess people bought them, and they are back now. So if you don't have this book, the previous one had an orange cover. If you don't have that one, you should buy this one. It's only $12, and this is an updated version with better pictures and more up-to-date information. So check that out. Thank you.
All right. Well, thank you very much. That is amazing that you got all that into 1 hour. That's spectacular, Robyn, I would say. All right, so we want to open it up to the floor to questions on the studies. Anyone? I had one question, actually. For your first comparative management style, I have this thing about the queen excluders. I played with them. Now, in that study, did you see anything involving side-to-side honey production for them?
Well, it's tough when you use a systems approach to know if it was the queen excluder or not the queen excluder that caused the differences. But really, honey production was not significantly different between conventional and organic, but organic did numerically make a little bit more and didn't have a queen excluder. So I suppose maybe that was the reason.
Maybe not.
Maybe not.
That's all right.
I have a question. Was there any correlation between the locations and the honey, the pasturage available to the bees? There are different parts of the state in Indiana. There's different floral sources going on in different areas. Were some people in a better honey flow than others? Did that go into consideration?
So he's asking if the honey flow in the different regions was considered in the study?
Yeah, or did show any?
Or did it show any differences between the different, were there big variations between the regions, or are they pretty similar?
Yeah, there's absolutely differences, you know? Could be a beekeeper effect or a location effect, which both of those were the same effect, right? So that's why in both studies we had everything side by side, right? So it's not like all the Indiana queens were in an Indiana apiary and the Pennsylvania ones were in a Pennsylvania apiary. You can't look at honey production in two different yards
But were
as your
they,
comparison.
so in each of the different regions though, was there the same variation between the different management styles? I believe is a question. Yes.
I don't have it broken down to that level.
But it wasn't obvious. It wasn't something that really spoke to you then. Okay.
That's Charlie.
Charlie, go ahead.
I think if I recall, the cone study was set up in somewhat organic. This is Charlie. So if I recall, the cone study was set up in somewhat organic regions, like you have an orange farm and things like that.
Yeah, so the treatment systems comparison, they were all placed on organic land.
That was okay. That's right. And definitely I might have mentioned that we were an outlier with I think our study with the Queen Project was because you're on optimum forage with Ernst line. Sorry, two short questions. First of all, was there any thought to do a study on Texas queens? They seem to be fairly popular around here in times. And the next question is, at the end of 3 years, is there any thought that regardless of the treatments, your mite population goes up?
CC, I couldn't hear those.
And so the first question was, oh gosh, Texas. Are you planning on doing any Texas queens? Any studies on the Texas ones?
I will defer you. I'll defer you to the Christina Grosinger lab, who is studying them.
Yeah.
So
And I'm
talk
sorry.
to Kate Anton.
Wait, the second one? The 3-year? Is there a specific reason that you think it takes about 3 years for the mites to explode in population? Is that, okay, that's a good summary.
I think that, you know, a brand new colony on foundation from a package is pretty safe for the first year, right? But you have to monitor in fall because, as you saw, the chemical free ones died over the winter with up to 4% mites, right? I think established colonies starting in year 2 are much more likely to have high mites, right? So, and then from then on, right? Because it's a continuous population. I really just think year 1 is special.
Go ahead.
Yeah, I understand that we're studying all the colonies with only mediums, means no deeps, all mediums.
In both of the studies, were they all in mediums? I don't believe they were. I think the first one was in mediums and the second was mixed. The second, yeah. The queen comparison had both deeps and mediums. Was there a reason for that? Is his question.
Because the beekeepers involved don't want to use mediums. And also, so I chose all mediums because I really like I like to be able to move my frames around as needed, you know. It's just very convenient for everything to be the same size.
And of course, Fred Dunn says, whatever. I saw
True.
more hands. Okay, so that about wraps it up. Thank you so much, Robyn, for being here.
Thank you for having me.
Okay. All right, so if you could send me that link and I will forward that to everyone tonight. So people
Okay,
can
you got it.
see. Thank you so much.